Start, huh? Okay, so yesterday I gave you the insight into the IT industry. What to learn and what not to learn, means what to do, what not to do. You have to decide your career, and finally your people have decided to do Java. So people have decided to Java for what? Bright careers. But again I have to justify that, how good your career is going to be. Simply telling Java doesn't mean. So today we'll start seeing still more deeper into why this language is more powerful, why it is successful language. All that information I'll give you today. History and all that I'll give you today. So anyway, we'll go to that subject later, but exactly what we are going to do in the course now. Okay, so see, why you have joined the course? Simple reason, you want job, nothing else. But to get into the industry, see, there are two types of certification required. First you understand this. There are two types of certification. One is what? Academic certification, and the other one would be professional certification. Academic certification you already have got. You don't have to worry about it. Either your B or MC or MTech or whatever it is, you already got it. Only thing what you lack is professional certification. What is professional certification? See, yesterday I gave you so many options for getting into the IT industry. So many options I gave. So once you get into the IT industry, okay, means before you get into the IT industry, you actually learn, update your skill set with those particular segment, whatever you choose now. Supposing you are doing testing, you will do certification there. Supposing you are doing Java, you will do certification here. Supposing you want to do Java, you will do certification here also. So these are called as professional certifications. And it's better you do this kind of certifications, because if you enter the company with this kind of certification, you will have some weightage. It's a add-on. It's a add-on to your career. So that's the reason. See, this you have already got. This you don't have. Right now your joint courses for getting this only. Okay, this is where you are bridging the gap. Okay, so this is one way how you bridge the gap between your knowledge what you have got and the IT industry. So this is how you are bridging the gap. So professional certification, see, example I tell now, if you are joining hardware and networking, there you will do one certification called as CCNA. Supposing you do SAP, so that time you will do what? SAP certification. Supposingly you do you join Oracle, then you will do something Oracle certification. So similarly, if you do join Java, you have to do Java certification. So these certifications recognize you a lot in the industry. So you might get a job without certification also. Later on you might do the certification irrespective. But always you have to get these kind of certifications. Okay. See, generally you get confused with certificates. Okay, when you join, see, you are all freshers, and you have to be guided very properly, clearly, because anybody tells you something, you blindly believe it. Here, whenever you join any institute, from that institute you will be asking for certificates. Okay, so we give certificate, it's of no use. Okay, but look at these certifications, who they are providing. This academic certification is provided to you by whom now? University, which is a valid, recognized center. Okay. Similarly, this professional certification is given to you by whom now? The inventors of that technology. Understood? Or the pioneers of that technology. Like, if you join SAP, SAP people will give you the SAP certification. If you do the exam for, or if you write the exam for SAP, SAP people will give that certification. If you do a Oracle certification, Oracle people will give it. If you do CCNA, that company will give you that certification. If you do Java certification, now Sun will give you that certificate to you. So like this, they are the people who give the certificates. That is having weightage, and that certificate is having recognition worldwide. When they give you that, when you do that certification, it is going to be recognized worldwide. But if I give a certificate from my institute, does it have any weightage? No. It might be a branded institute also. Institutes don't carry any weightage. We are looking for a deemed university here. Okay. One is academic certification, yes, and this one is professional. Now why both are required? Because see, whenever you go to different countries, the education system varies. Okay, in India we got B, but if you go and tell in US you are B, they don't understand our education system. Okay, so they generally ask you, you are a professional in some stream, have you done any certification in that stream? That's what they ask. So to make yourself, to get yourself identified, or to have an identification for yourself, you will do this professional certification. Understood? So see, this is mandatory, I'm not telling no, but along with that, professional certification also becomes highly mandatory. This you already have, this you don't have. So to do this, here, now see, now getting the certification done in which one? For getting your academic certification, how many days did you take? You took 22 years. Not 4 years, not days. You have taken 22 years to get one academic certification. Okay, means it started from LKG, UKG, first standard. There it starts. Because say, if you want to do academic certification directly, can you join BE? Not possible, no? You have to go with this process. Okay, then you can write your BE exam and clear it. Similarly, to do a professional certification, there is some time requirement. You think about short-term courses, fast track. You cannot do it because there is a time bound for everything. So, like see, I am going to train you Java now. After training Java, you have to get certified now. So to get this certification, minimum you require is what? 4 to 6 months. Minimum 4 months of effort is required. So once you do put this much of effort, what happens? Not only this Java certification, any certification you take here, minimum duration to get that certification is what? 4 to 6 months. It might be SAP, it might be Oracle, it might be CCNA, it might be Java, any certification you tell. Minimum duration required is 4 to 6 months. So, and this is your career now. This professional certification is your career and you have to put 100% effort to learn into this. So here to get this professional certification, here in our Java segment, we call this certification as SCJP, Sun Certified Java Programmer. There are 3 certifications here. What we provide here, there are 3, SCJP, SCWCD and SCBCD. We provide you training on these certifications. Along with that, little database certifications also we provide in Oracle, that also we provide. The full form of this is Sun Certified Java Programmer. Understood? This one is Sun Certified Web Component Developer. The last one is Sun Certified Business Component Developer. And Sun is certifying you. Like that, there are many exams here. But minimum, company expects you to complete this, at least. Minimum to 1 level. Database also on certification is there. From Oracle there is some certification. Okay. That is for database, live. We are talking about Java now. From Java, there are 3 things. Now this SCJP is also known as nowadays OCJP. Are you aware of this, sir? Okay, means I'll write it here, OCJP. You know what is OCJP? Oracle Certified Java Programmer. Similarly, I got OCWCD. Similarly, I got OCBCD. That has been replaced. Because Sun has been taken over by Oracle company, that's why that has been renamed to what? SCWCD, this one, 3 things now. This is one, this is the other one, this is the other one, 3. And extensively means minimum this certification is required for you to enter the IT industry. Are you clear with this? Minimum, this is required for you to enter the IT industry. So to do that certification, okay, you have to learn Java properly now. You have to learn Java properly. To learn Java, language is only one. See, if you wanted to learn English in your college, school days, how many books you referred to? Minimum 5 to 6 books now. But language ultimately was learning what? Only one. English only you're learning. But so many books you referred. They are teaching you the same language in different dimensions. So similarly to learn Java now, what we do is, we refer to some 3 books to learn Java. Okay, all are having the same content, but it is the way of expression the author tries to express, means or tries to explain. They are having their own explanation style. So if you refer to 3 books, automatically you get the clarity. So 3 books which we refer consistently here for learning Java are, and if you learn these 3 books, you can automatically what? Balaji, complete reference. So for learning these 3 books, okay, I'll be showing complete reference. Okay, so one would be Java complete reference. The author is called as Herbert Schilt. So we are going to learn, means I'll be teaching you from these 3 books only now. Herbert Schilt. See, we are actually going to learn Java from certification point of view. Imagine now. So we are going to cover SCJP syllabus. So one is Java complete reference. One book what we are going to refer is Java complete reference. Author is what? Herbert Schilt. The next book would be, you got this book now? Java Complete Reference by Herbert Schilt. Next book could be Head First. Okay, next book would be Head First. So here the author is Kathy Sierra. Head First. Head First Java, Kathy Sierra, author. And the last book would be this one, SCJP book. The last book would be SCJP book. Means uncertified Java programmer. If you do these two, now reading this book becomes very easy, and the author for this is also Kathy Sierra, same author. So if you read these three books, you can do the certification. But don't look at the size of the book now. Okay, or you have to read so many pages. You believe or not, in that language is hardly 200 to 300 pages. So Java is one of the easiest language. And then what are the other pages containing now? Nothing. They contain only libraries. Libraries, you know libraries now? You want to write some code. Okay, so don't write the code. That code is already existing. It is there. So you just have to use the existing libraries, nothing else. Understood now? So hardly 200 to 300 pages in every book. That's it. One of the most easiest language to learn on earth is today Java. Yeah? You want proof? I'll start giving you more explanation on that. Okay? We'll see, because you're thinking Java is difficult. Java is the easiest language. Let's see how easy it is. With proof only I'll show you. So anyway, before getting into the IT industry, these things should be clear to you. So whatever stream you choose, first you have to get what? Certified. And if supposedly if you have chosen Java, you have to get Sun certified or Oracle certified. Oracle certified Java programmer. SCJP is now known as OCJP. Are you clear with this part now? Are you clear with this? Okay. Then next, we'll start getting into learning Java. So I've just told you now what we are going to learn throughout the course. So our focus is this now. Our focus is this. Okay. So if you can do this, fine. Then anybody can give you the job. Okay. Clear this? Fine. So we'll start off by learning Java. Now what is Java according to you? Java is a programming language, all of you say. But let's go from the scratch. 5 minutes we'll start from the scratch. Okay, because there are so many E&C people, computer science people. Okay, some people think, okay, if it's better I start from the scratch. So it's start from the very scratch, no problem at all. Okay, so the scratch is now computer. What is a computer? We'll start from there, forget language also. What is a computer? Huh? What is a computer according to you? So a computer is a machine which can execute some set of instructions. Yes or no? Computer is a machine which can execute some set of instructions or a simple program. That's it, nothing more. Computer is a machine which can execute some set of instructions or a program. Set of instructions is nothing but a program now. Fine. So a computer has been developed and it can execute some set of instructions. But what are those set of instructions, or what do you mean by a program? What do you mean by that? See, programs here, what is the thing man is trying to do is, earlier man was trying to do many things manually. You can go on doing everything manually, means using books, paper, pen and all that, you can do it. Like doing addition for too many numbers of, means you want to add too many numbers, or you want to multiply too many numbers. Not these are small things what I am talking. Okay. So these simple things also, man was doing it manually. Later on, he got, means see, as man goes on doing it redundantly, what happens again and again, you lose accuracy and you lose performance also. So that is why these tasks, what you do again and again every time, we try to automate it. Automate it by doing what? By giving the control to machines. So you develop a machine in such a way that it can execute these things for you. Instead of you doing, you'll give the control to the machine. So you'll write some set of instructions now, or you'll write some program and make the machines work for you now. This is the idea of programming. Are you getting the idea of programming now? So you write the code and you make the machines execute. You get the work done by the machine now. This is the actual process. So computer is going to do that, nothing else. Now for writing that code, you have to choose some language. Understood? You have to choose some language. So which language you choose? That is the question now. So we are going to discuss that. So in the history of computers, two things are widely discussed in the history of computers. One would be what? In the history of computers, two things are discussed extensively. What is that? One is the language. and the second one is programming model. Programming. Two things are required now. So what is programming now? A writing set of instructions or writing a program is called as what? Programming. Writing set of instructions is called as programming. Fine. To write that, what you need? A language. You're getting now how they are linked? So computer needs these two things. In computer it's a very big subject, but these two things are essentially to be discussed today. So now to program, a lot of things happened. For programming, see, what happened, like there are too many programming models which came out. Are you aware of these programming models? Okay, so to program now, there are so many programming design or models which came out. Okay, they are called as modular programming model. Then you got top-down programming model. Then you got top-down, bottom-up programming model. Then structured programming model. So many structured programming model. So many programming models came out in the market. Why these many programming models came out in the market? Each programming model was solving one particular problem. What those problems are, I'll start telling you. Okay, so see, when they wanted to write some program now, initially they were writing very small programs, like say 10 lines, 20 lines and all that. Later on, when they were able to write 10, 20 lines of program, they thought of writing little bigger programs, which they are unable to do. Okay, so that's when they thought of some other programming model, like top down, bottom up. So many programming models came. So initially what happened, there were some languages. Now the question is, why so many languages are there in computer? Why there are so many computer languages in for programming? You got so many, plenty, more than 1,000 are there. Why did so many computer languages came, and which one is more important for us to learn? That's becoming the question. See, initially what happened was, I'll tell you that story also. There are so many programming models. To suit this programming model, one language was coming. Initially something like Pascal, Fortran and all came. Then for supporting structured programming, which came, C came. See, like for this one, Pascal and Fortran were supporting some other type of programming, but C came and started supporting what? Structured programming. Okay, so like that, to support one programming model, one language was getting invented. That was the problem. And finally one programming model came called as object-oriented programming model. This is the most successful programming model today, object-oriented programming model. So you get the idea about what is programming model now, or design. So many are there, just I have listed few. And on top of that, to suit one programming model, many languages came, like C, Pascal, Fortran, many came. And one language is suiting what? One programming model. So as and when the need changed, one new language was coming out. Supposingly one programming model came to support that need, existing language was unable to satisfy that programming model. So one more new language was invented. One more programming model came. Means many used to come. Not only one language, supposingly modular programming was there. Many languages came to support modular programming. Among them few were popular. Now which one gets popular? The most user friendly one and most powerful one. So the developer is asking for big things now. He wants a easy language also to learn, as well as a powerful language. So this is what he's expecting, easy and powerful language. So when top-down programming came, again he wanted the same thing. Like that many languages will come, and among them few will become popular. Not all will be popular. So which are very popular we learn, which are not popular we leave it off. That's how it goes. So this one just idea about history of computer. I just told you what is computer, what is programming, and what is a program, and to program what we need, language and all that. So now let's start saying the history of languages now. Clearly we'll see the history of languages. So why I'm telling you all this story now is because you people are having one big question now. Can I learn Java? Can I do programming? I am from this background, I am from that background. You have certain questions. You don't have to worry. The history will give you the answer for all that, all your questions. History will give you, I am not giving the answer for that. History is going to give the answer whether it is a user-friendly language or not. Understood? Based on that, you can start putting effort and when you put effort, automatically things will become easy for you to learn. So history is very important here. Are you clear? Okay. So let's see this. Shall I clear all this now? History of computers, these two programming model, and both are required now. One model also you require, and as at the same time you need a language also. And don't go deeper into all this also. Just I'm giving you an overview, like how a computer came into existence, how languages came into existence, and which is the good language, and which is the best language, and all that. Okay. See, initially, as I told you just now, program is nothing but set of instructions. So to write those set of instructions, a machine was invented, but the machine or the processor, to be very precise, okay, was designed to execute only what code? Binary code. They designed the processor to understand and execute only binary code, nothing else. So 1010 code only it can understand and execute. So initially coding was done in binary language. So history goes back now. I'm talking about 78 years of history. Now nobody is going to learn binary language. But just I'm telling you the history. Okay. So initially the first language which came out for programming was binary language. Understood? Programming started off with binary. And here they code with 1010. Like what you write now in C language, int a is equal to 10. These are high level languages. But earlier they are coding in binary. Okay. So imagine now coding here was very difficult. What are the drawbacks here? See, advantage was there. Like if you write some code, it was getting executed. But there are a lot of drawbacks. It was not user friendly. Understood? Very difficult to debug. And you could write very small programs, like say 10 lines of code, 20 lines of code, like that. So there are many drawbacks with this language. Understood now? So the first language which got invented had some problems now, or drawbacks. What are the different drawbacks? List. Drawbacks of binary language what? Very small programs you could code. You could code only very small programs. Then came what? What are the other problems? Not user friendly. Means not user friendly means what? You can't understand this and code properly. Not user friendly means it's very difficult for developers to learn and code. You're telling C is difficult, no? Int I is equal to 10. What C is difficult? See, earlier they're coding in what? 1010. Int I is equal to 10. You write stylishly today, no? This is high level. You tell this is difficult. Imagine the same code earlier has to be written in what? Binary. Which one is easy now? And then you tell this difficult. Imagine what is your effort of learning. Understood? So I'll tell you the history. Automatically you'll only understand now which is easy, which is not easy. So earlier this was the difficulty. It was not user friendly. Very small programs you could write because it was complicated. Debugging was difficult. Maintenance was difficult. Debugging and maintenance was very difficult. Like this, there were plenty of problems, man, with binary language. That is when they thought of inventing one more language to overcome these problems. See, simply languages will not come every day and night. Today something is there, tomorrow one more will not come. Tomorrow, day after tomorrow, one more language will not come. There is a particular reason for that. Okay, until unless there is a valid reason, simply they will not go on inventing languages now. So then came, the next revolution was assembly language. Now, assembly language is also, here what we do, instead of using binary, we use something called as symbolic representations. Symbols we use for programming in assembly. This is also very complicated. Okay, so here assembly language, there are so many problems. Few problems it resolved, not all. Okay, in one day they cannot solve all the problems, man. Step by step they'll go on. Okay, so here what it had also some advantages. Some advantages was we could write little bigger programs. That's it. Again, so many problems continued. What are the other problems which continued? It was not user friendly. Debugging maintenance was a problem. Okay, but only one advantage was, compared to binary language, you could write little bigger programs. Okay, so the size of the programs were increasing. Why they are increasing? Because man's requirement was increasing. As the man's requirement goes on increasing, the size of the program will also increase. Requirement means what? Something like you want to do more and more computation. Understood? For that what will happen? When you want to do more and more computation, more logics you have to write now. When you want to write more logics, the size of the program increases. So that will be the problem. So here advantage was there, but we can say more of drawbacks were only there. It was not, see, you could write little big programs, that's it. Not very big, little bigger programs. Like here if it was in binary language, if you are writing 50 lines of code, here you are able to write 100 lines of code. Something like that. Okay, very small only. And those days, these were big inventions. I'm talking about story of 1950, 1960. What story I'm talking now? We are talking about 1950 and 1960. Much before we were born. So a little bigger programs, but then what? Not user friendly. Same problems continued. And debugging and maintenance problem. Because here they were using something called see here they are using binary 1010 like this they were coding, and here they are using some symbols. I don't know what symbols, but like this they are using some symbols for programming. Understood? So that is how assembly language came into existence. But again, learning and coding was very difficult. So now see what was happening. Man's demand for software was increasing and increasing. He wanted to write bigger programs because he got the taste of it now. He wanted to write bigger programs, but here the support from the language was not there. No language was supporting that. So man's demand for software started increasing. He wanted to write many softwares, but the problem is there was no language to support that. So that is when a lot of research happened. And the first thing what they're looking was now it should be user friendly. And the next thing what they're looking for us, it should be means using that language you should be able to write bigger programs. These were the two main things. Like that, many problems were there, but these were given more preference now. They wanted a easy language, okay, and they wanted to write bigger programs. These were the two major problems, okay. And the performance, that one will come now. Performance should be better, okay, and quality should be good. The rest all things are there, but these were the two highest priority things now. To overcome this, to make it user friendly, what happened? They started inventing high level languages now. You know what are high level languages now? What they do? High level languages. So we code in high level, where you can learn and I can learn. It's very easy to learn now. So what we do for learning it is easy. So we'll code, and this language can be understood by me and you, but that language is not understood by the processors. Okay. So what happens now? After coding in high level, we compile it. Why do we compile? So that it is converted to binary code or machine code. That's much better now. So instead of directly learning machine level, what you will do now? You will learn high level coding. And once you learn high level, you will compile and then you can execute. So that's how we will do now. We code in high level, then we compile. So this is much easier as compared to directly coding in what? Low level or machine level. So that is when many high level languages started off coming into the market. Okay, initially many came, Fortran, Pascal, Basic, many came. Okay, but they are unable to, again, they were user friendly, but again they had their own problems. They were unable to support what? Big programs. Means again the size was increasing. Like what happened here, 100 lines of code you can write. There you could write 500 or 1000 lines of code. But again the man's demand for software was increasing. He wanted to write still bigger programs. So the demand for software was increasing. At the same time here there was no support for language. So these were the problems. Okay. So anyway, see high level languages started entering the market like Basic, Fortran, Pascal, Lisp, Algol, BCPL. The list is endless, man. I go on writing, it's of no use. The list is endless. Many languages came. These were all high level. Understood? What is the advantage of all these high level languages? Because to learn it is easy. And later on, after learning it, what will you do? You will code. Coding will also be easy now. Debugging is easy. Maintenance is easy. Only one advantage is what now? You compile it, it will generate into machine level or binary code, and then it will start executing. So many high level languages came. But among them, C was very popular. Among all these high level languages, what happened? C was very popular. Now again the question comes here. Why so many high languages came into existence and why C was popular? Among all these high level languages, okay, first of all, why so many high level languages came? And second thing is, among all the high level languages, why C is so popular? This is the next question what we get. Let's see the story here also. See what happened here when they came to know the difficulty of programming, because as the program size was increasing, okay, development was becoming very difficult using these languages. So parallelly what they thought of, apart from inventing a language, they are thinking of about parallelly inventing some programming models. Okay, so here see, that is the reason so many languages are existing today in the market. Like as I wrote, modular programming model, yes or no? Yeah, here you have your many here. There are so many programming models. Modular programming model. Then you are having top-down programming model. Then you are having bottom-up. Then you are having structured. So many programming models came. And one language, okay, again it's a history of 20-30 years. First one came, then next came. So one language came to support one programming model. So many languages came, but not always supporting structured programming model. Structured. So then by the time all this got invented, one programming model was becoming very popular. Which one was that? Structured programming model. This was becoming very popular. And that is when C got invented. So C started supporting what? Structured programming model. It's a procedural language. C is a procedural language and it supports structured programming model, and it became very popular. The reason why it became popular is it was first of all user friendly. First main thing about C was why it was popular was it was user friendly. Next thing is it was following structured programming model, and C became heavily successful in the market and it dominated the market like anything. Okay, but again there are problems existing in these high level languages also. Can you guess what are the problems? So this is a high level language now. So we are talking about high level languages, and in these high level languages C was very popular. Many are there, but among them C was popular. Reason is it was following which model? Structured programming model, and it was a high level language. Rest all flopped. So now to learn C, will you go and learn basic Fortran, Pascal and all that? No, you tell no, to learn Java you have to learn C, C++. That's why I questioned this. To learn one language, you don't have to learn other language. It's only a myth or assumption. To learn one language, what? You should learn another language. It is wrong. To learn Sanskrit, you learn English. You have this confusion. To clear that confusion, I am taking this class for you. Because your question is what? Can I learn Java without C and C++? This is your question? No. I am proving that now. See this. And I have to prove it what? History. My words will not talk now. History will tell you that anybody can learn Java here. Understood? So now, see, you are telling, one more we'll see now. You are telling C is difficult. Now compared to these languages, which language would you prefer to learn now? C only, no? Then why are you telling C is difficult? So you are having some problem with what? You are having learning attitude problem. So you should change your mentality and start learning now. Simply don't sit cribbing. That is difficult, this is difficult, this is difficult, that is difficult. Whatever you're interested, put effort, automatically it becomes easy for you. Are you clear with this? Okay, fine. So C is easy as compared to what? C is the easiest language as compared to all this now. But again, structured problem, there are drawbacks. Here also they were drawbacks. I'm not saying no. What were the drawbacks in structured program means? What were the drawbacks here in these high level languages? They were user friendly. But again, as you got this kind of a support now, man tried to invent or develop still more bigger programs. The size of the program, there is no boundary today. Okay, the size of the programs increase, and today we develop so big programs that it's very difficult to control and manage. The size of the program started increasing. Okay, here again, a limitation of what? There's limitation of size of program. There's limitation. At a certain point you find that even, see, I'm talking about structured programming. See, all these are okay, but structured programming was becoming popular. Okay, and most of these languages were following structured programming. Okay, and there was problem here also. What was the problem? They were high level, correct, but they had their own limitation. Limitation of size of the program, and there was no high level of reusability. They did not have strong means or very, we can say, no good support for reusability. I'm bringing two words now: reusability and avoiding complexity. There are many problems, but these two were the biggest problems. So So to overcome these problems, means one word what I'm bringing newly is what? Reusability and avoid complexity. Now what do you mean by that? Reusability and avoiding complexity means write the code once and run it anywhere now. You should be able to run that code where? Any operating system, any hardware and all that. C was not giving you that support. You write a program in C, it will run in only one operating system or one hardware, one device like that. Okay, there are problems with C programming. I'm not telling C is bad. It has its limitations. C is used for a different purpose of programming. C++ is used for a different purpose of programming. Java is used for a different purpose of programming. All have their own segment. So in some places you have to use C only. In some places you have to use C++ only. In some segment you have to use Java only. None came to overtake the other. There were some set of problems which C was not solving in some particular segment. That time a new language came there. Some more problems were existing there. That time one more language came. So like that, languages keep on getting invented. Problem comes for that segment. See, C will be supporting something. Okay, C language will be supporting some programming, but they'll try to do C programming with some other thing. It will not happen. That time they'll invent a new language. That language is not coming to replace C now. Understood? C++ did not come to replace C. Java did not come to replace C++. They had their own problems, and to get that solution they started inventing these languages. So then these were the problems. To overcome this now, one new programming model came called as OOPS. To overcome all this means because you couldn't write bigger programs. So here in OOPS programming what happens, we'll start splitting the code into small classes and all that. Now you can write any big program you want. If you want to write a program of 10,000 lines, 20,000 lines, what do? You start, instead of writing it one by one like C, procedural. Okay, what do? We'll start splitting the code into, organizing the code into something called as class and all that. We'll see all that later. So OOPS talks like that. You hide your code in one place, and whenever you want to use it, start using it. Okay, so here you can write any size of the program. The size of the program can increase drastically here. So this supports that. So OOPS was invented, and when OOPS was invented, many languages again came to support what? OOPS programming. Many came. Again the list you see here. Some of the languages which came to support OOPS was what? Simula I think. SIMULA. Simula. Then you have ADA. You got COBOL. You got Smalltalk. Many are there. Many languages came to support what? OOPS programming. Now all are not successful. Why? They were not user friendly. Developer should have the ability to learn, no? So he's looking for a user friendly language, as at the same time it should be powerful. Two things we are expecting. Plus powerful. So two things. So that's the reason, okay, these were not popular, and then what happened? C++ came out and it was highly popular. You know why? It was user friendly. Everybody knew the syntax of C, how to write code in C. Okay, see, coding in high level is very easy as compared to binary, you know that. Yes or no? Now writing, see, if I want to declare a value 10 and store it in one variable, in high level you write like this. In C you write like this. In COBOL, no, you write like this. Number. See, this is C, this is COBOL. So just see the difference between high level languages also. In C you write like this, and then here you write number I is equal to 10. Here you put semicolon, there you don't put it. Then again if I want to write int j is equal to 20, so I'll also write number j is equal to 20. These are high level languages. Here also see, I'll write j greater than I. Here how will you write? J GTI. I've just written two languages. Which language would you prefer? See, no? Why? User friendly. As simple as that. Just 3 lines. You start deciding like this. By looking at 3 lines, you start deciding the language. So that's when C became popular, but it had some problems. Okay. So similarly, see, this is what I mean by syntax. Okay. So when OOPS came out for programming, OOPS was introduced for programming. OOPS means what? Object-oriented programming. Okay. In OOPS there are 4 features. We'll see all those 4 features. It came out and many languages tried to implement it. So what these languages did was, they had their own new syntax. New syntax they had. Plus they had OOPS. Now 2 things to learn was very difficult. If you ask a C programmer, C had already dominated the market. For that programmer, if you ask to learn a very new language with OOPS and all, he was not ready to learn, because it was not user friendly. They are also finding it very difficult like you. You say no, language is difficult, and same way, you are all developers. So they refused to learn. So that is when one group observed. What they thought? We only have to add oops. Let us take the syntax of C. So what did that person do? He took the complete syntax of C. Nothing he did. Full syntax. You know C, no? How do you write int I, for loop, if block, else block, whatever. Control statements, all that. He took full syntax. Pin to pin. Only in that he added oops. That's all he did. Now people started migrating. Because they knew the syntax. Only they had to learn what? Oops. Okay. So C++ became heavily popular. And in oops, what is there is, see, there are 4 things. You have encapsulation, inheritance, polymorphism, and abstraction. In oops, there are 4 features, and you think it's a very big subject and all that. Don't think. See, it's very simple. All these 4 concepts came to solve only 2 problems. What are the 2 problems it came to solve? All these 4 means actually oops was introduced to solve 2 programming. One is reusability, and second one was to avoid complexity. This was the main intention. Avoiding complexity. Means oops was a programming model, and it was invented to solve these 2 major problems. They wanted to reuse and avoid complexity to a greater extent. And that is why oops released 4 things. What? Encapsulation, inheritance. We'll see all this in detail. You don't have to worry. I'll be telling you in this. Programmatically only will be saying this. So they released these 4 things. And all these 4 things are doing what? Solving only these 2 problems. Means encapsulation also helps you to do what? Reuse, avoid complexity. Nothing else. So if you implement encapsulation, it helps you to reuse and avoid complexity. Now inheritance also will solve what problem? Reusing, avoiding complexity. Polymorphism, reusing, avoiding complexity. Abstraction, reusing, avoid complexity. All the 4 are giving the same support. But in one scenario, you will take one support. Means sometimes you will do encapsulation for using and avoiding complexity. Sometimes you will use inheritance for using and avoiding complexity. Sometimes you will use polymorphism for using and avoiding complexity. Sometimes you will use abstraction for using and avoiding complexity. Because only encapsulation will not solve you the complete problem. Some scenario you have to go for encapsulation, some scenario you have to go for inheritance, like that. In one scenario you have to go for one support. So that's why oops gave 4 things for reusing and avoiding complexity. These languages tried, but they are unable to implement it properly. Now again, they had done it. Among them C++ won the race. But again, C++ was not popular. Can you tell me why? Little time it dominated, but it was unable to dominate completely. So there were some problems here also. Now see, there were some languages, Simula, Ada, COBOL, Smalltalk and all that. They had brilliant implementation of oops, but they are not successful in market. Implementing this also is very important. No, language should support this too in a great way. But some languages are supporting that, but they are not successful because they are not user friendly. C++ does not have proper implementation of oops. It is wrong. Means so many things are not implemented properly here, but still it was popular. Reason is what? User friendly. So sometimes if it is improper also, man tries to use it because it is user friendly. That's what happened. Okay, and somehow it was dominating the market for a certain while, no problem. But again, here what was happening was, now programming means programs were getting increased, size was getting increased, too many programs we had to code, and programming had to be done for many devices. It's not that only computer, they were thinking of programming for what? Small electronic device also. Okay, so all these problems came. So now the code what you write in for once, they wanted to run it, to reuse it for a high level. They wanted to reuse your code, means once they write a program, they wanted to reuse it in many places. It can be in any hardware, it can be in any operating system, it can be in any processor. This was their idea. Now all these languages were not supporting that. The reusability level was very low. That's simple word. The reusability level of these languages was very low. Example I'll tell. Supposingly I want to write a program for one TV. I'll use C++. So in TV, what will happen? I'll have one processor. Okay. So now you have to design means you are having C++ language, but you have to design a compiler for that processor now. So now designing compiler is no joke, because for one device, one processor, designing compiler means what? Program is same, but you have to again compile and run it now. It was becoming very complicated. So a code written once could not be executed in many places. So they wanted a highly reusable program now, language, a highly reusable language. Okay, and it means, and avoiding complexity means what? You're not going to code again. You'll just use it. So these two words, actually they look similar now, but later on you'll understand there's a big difference between reusability and avoiding complexity. These languages were not supporting that. That's when in one company called as Sun Microsystems, company name is Sun Microsystems, research was happening and one language was invented called as Oak. Now when these language was getting invented, what they thought we'll take complete syntax of C. They knew the full history. This happened in 1991 now. Okay, they knew the full history. It started in somewhere 1950 and in 1991 they are doing some research. So it's a 40 years history they had, and they knew if they go for binary coding, assembly coding or low level languages like which one? Machine level binary and all, it will not be successful. High language would be successful, fine, but which high level language to choose? Like that they did a lot of R&D, and they were brilliant programmers also. So what they thought, if they use the C syntax, automatically people will be ready to learn it. They knew that. So that's when they thought, let us take C syntax and let us implement OOPS properly here, and at the same time we'll give a highly reusable language. Means if you write the code once and if it is compiled, it can run in any hardware, any operating system, like that. It was something like write once, run anywhere. They were coming with an acronym, VORA. VORA means what? Write once, run anywhere. Means write your program only once and run it anywhere. It will not depend on hardware, it will not depend on processor, it will not depend on operating system, nothing. These languages were not supporting that. Okay, so this was their idea. So what they did, they invented a language also called as Oak. Okay, Sun Microsystems invented a language called as Oak. For that they took the syntax of C and whatever problems were there in C++, OOPS, they refined it, they removed that, and in some other languages OOPS was implemented in a beautiful manner. They took there, means mix and match, what is good from this language, what is good from that language, all the best things they took, and finally they came with a refined language, fully refined, no problems only. They knew all the flaws, they knew the problems of what? High level, low level, so they picked the high level, C syntax they picked, best implementation of OOPS they picked from all the languages, and finally they invented a language called as Oak. If you write the code in this language now, what happens? It can run in any hardware, any operating system. It was highly reusable. You just have to write it once and compile it once, and then it becomes highly reusable. How it is achieved, tomorrow I will be telling you. How Java is a highly reusable language, how it becomes portable, means how you write the code once and you can run it in any operating system. From tomorrow you start seeing it. Understood? Later on this Oak was renamed to what? Java. The same language, they renamed it. So Oak was renamed now to Java in 1995. So Java is having a history of 23 years now. And it's a refined language, nothing else. It is having the complete syntax of what? C, and the best implementation of OOPS. Remember that. It is having the best among all the languages available in the market. It is having the most powerful implementation of OOPS. Understood? So here what happens? So Java language. So what are the advantages now? Here you will find only advantages. There are very few disadvantages you find here. Literally no disadvantages only. Okay. Best implementation of OOPS. Or strongly supports OOPS. Then what? Second thing, user friendly. That is very important now. So you only see now. Java is easy or difficult? Easy actually. Because I am not telling the story now. History is telling it. Now you want to learn Java or you want to learn binary, you decide. Yes or no? You have to decide now, very strongly you have to decide. So then user friendly. Then next, here lot of advantages are there are no disadvantages. VORA means portable. Write once, run your code anywhere. Portability. I guess plenty of advantages are there. All those advantages, if I tell you now, it will become technical jargons or you will not understand those words. Time being, what you can understand, only that much I am telling. Memory, see, if you see here, except sliding is good, memory management is good, many things are good. Let me not get into technical details now. Okay, we'll be seeing that when we go on learning the language itself. But this is the history of the language, and once they invented this language, they came to know if you write the code once, you can run this code anywhere now. That is why Java started later on releasing only libraries. Library. Will not code only here. Because the problem here is, in other languages, they can't release library. Why they can't release library? Because if they release the library, that library will work in only one operating system. That's the problem. Again, for another operating system, they have to release another set of library. But in Java, that's not the case. If they release the library, and if you learn it, it will run in any operating system. So Java language is very simple here. Hardly few things are there. If you know C syntax finished, we only learn what here? Oops. That's all you're going to learn here. Okay. See, it doesn't mean that to learn Java, you learn C++ and come. Actually, why are you going to learn C++? To learn oops. I'm telling you very clearly, oops is not implemented properly there. So imagine now, you'll go join C++, you'll learn it also. I'll only teach you. If I teach you what will happen, it will take 2 to 3 months. After 3 months, I'll start teaching you Java. Then I'll tell, this is wrong, oops, it is removed in Java. How do you feel now? You only see how you feel. Means this is wrong concept of oops. That's why Java has removed it, I'll tell. Why? It's a refinement. But your 3 months of effort, who will give now? So it's better you learn oops directly in Java. At the end of the day, see, you are going to go, you are planning to learn C++ was only one reason.
But still some companies hire.
No, that is a different segment of programming, I told you. We are not talking, see, his question is, still some companies hire for C++. Their requirement for programming is different. We are talking about what? Internet programming. Yesterday we discussed what is the type of application we want to develop. Understood? We want to develop what now? Internet programming. We decided now. In the IT industry, I want to get into the segment of what? Web-based applications. If you want to develop a web-based application, which is a language which is going to be used now? Not C++, Java. So if it comes to internet programming, Java is the front runner. So there's no question of C++. I told you, Java is not replacing C++ very clearly. Okay, there are some set of problems to be addressed. That's when a new language comes up. So Java is supporting you programming in a different way. C++ is supporting in a different way. C is supporting in a different way. Okay, now which companies recruit programmers for C? Embedding companies. It is as simple as that. So recruitment will happen for C also, it will happen for Java also. Doesn't mean that only recruitment is going for C, for Java. Wherever, however the requirement is, they'll go on recruiting now. Clear? Fine. So this was the idea, and Java started becoming heavily popular now, and it's a highly reusable language. And here, in fact, we are going to develop big applications, I told you, but fully libraries are there, ready-made libraries. You don't have to worry anything here. Only some basics, language you have to learn. And you believe or not, to learn C, C++ and all, minimum duration taken is what? 6 months, 7 months and all that. In fact, 2 months we finished the language here. And 4 months we practice how to write applications here. That easy it is. You can't think of developing an application. Can you develop an application in C within 6 months? See, one side you have to see language. At the same time, other side what you have to see, using the language, you have to do something practical. Now, practical here means not writing simple programs like int I is equal to 10, int j is equal to 20, k is equal to I plus j. They are not practicals. We have to see how it is used in real life programming. Understood? So Java language is completed just within 2 months. Rest what we'll be doing is what? Developing applications. Again, for developing applications, we don't think too much here. Okay, everything is in library. Supposing example, in C, I want to store some values in data structures. You have to sit and write data structures there. But in Java, what happens? Ready-made. You know what are data structures now? See, we have to hold values in primary memory. For holding values in primary memory, it will depend on what? Data structures. In C, first you have to design it. Then you have to use it. But in Java, what happens? Data structures are ready-made. Example I am telling you. One of the example for library. Understood? Like you have linked list, array list, tree set, hash set. Which structure you want? Directly start using it. I want to get database connection. 2 lines of code you write in Java. You'll call some function. That's it. Library. You'll get the database connection. So easy it is. Now these things are not possible with what? Other languages. And why they write so many libraries is because Java is platform independent. There's a technical reason for that. So imagine, literally end of the day, here we don't code anything. We are only going to use the library. So initial 1 week, 2 week, what happens is little effort you have to put to get adjusted to the language. Understood? See, if you want to learn English also, you have to put some effort now. How does it start off? A, B, start off like that. And you have learned English for how many years now? 22 years. And still, how good you know the English? You know very well. Some people are really good, some people are bad. But you have learned, all of you have put effort and learned English for how many years? 22 years. Now one language, one speaking language, one communication language, you are taking 22 years to learn now. Understood? Now you want to talk with the computer. Understood? Means you are learning a language to give instructions to what now? Computer. Now that how will you learn in 2 months? You are learning to talk with a machine now. So to talk with humans we take around 8 years, 10 years, 12 years to get professionalism. No, learning is not a simple thing like it's not like, okay, if I know A, B, C, D, I know English. Okay, if you know how to build sentences, if you know how to write paragraphs, then we say we know English. Similarly here, knowing int I, int j doesn't mean that I know the language. If you know how to write bigger programs, then we can say I know the language properly. Understood? So this is the story. So just I gave an idea, insight into this one now, language. So it's one of the most easiest language. All you have to do is what? Put some effort. And here, see, Java is following 100% C syntax. What you write in C, initially first week I'll be teaching only syntax of C only here. Like how you write variable, same thing, there's no difference. From tomorrow I'll be coding. Same things will be there. What you saw in C, same things will come out here also. Only extra what you are going to learn? Oops. So to learn oops, we will be using Java, not C++. That's it. You think it other way around. So once you know oops, you can, once you know oops, after learning Java also you can go and learn what? Ulta you do know, you can learn C++, but there is no use. How many languages you want to learn? Be a professional in one language. One language you should be master. After learning oops in Java, you can learn oops in what? C++ also. Ulta you can do. But don't do it. You are unnecessarily wasting time because you have already decided to do Java programming. But I just told you. Just I brushed up your mind that without C++ also you can learn what? Java. And this is history what it is telling. One of the easiest language. Clear with this? Still you have any questions here?
So then can't we use Java here in place of C and C++?
No, I told you everything has a purpose. Now can Java replace C? No. I told you there is no replacement. See, so many languages are there. Now what Pascal can do, C can't do. What C can do, Pascal can't do. Similarly, what C can do, Java cannot do. Why are you comparing C and Java? Otherwise, if one language only could give all the solution, why so many languages would have got invented? They wouldn't have wasted time. Only one language, they would have gone learning everywhere now. Understood? See, all these languages are not replacement. There is a problem, one new language. There is a problem here. One language supports modular programming. I want now top-down programming. So what will happen now? One new language will come. Understood? That language cannot support this. So one problem will be there. Understood? So only one language cannot solve you all the problems. But here, for internet programming, Java is dominating. And once Java became popular, many languages started following Java. The same way they started inventing. Like, one of the example is what? C#. It is coming from which one? Microsoft. So since Sun released Java, these people released what? C#. See, they are good in office products, but they want to enter programming segment. But they are not able to do it. It is following fully Java, it is following. Which one? C#. Understood? So we saw the history from 1950 to what? 1995. And we are sitting where now? 2013. You are a 2013 pass out now. Still it continues to dominate. Which one? Java language. See, so many, I listed few languages. You take out the history of computer languages. History of computer language you type in Google, you'll find out. Thousands of languages will come out now. Programming languages. Okay, thousands of programming languages will come. You have to decide among one now. And then you enter the IT industry. But you know how good you know this language now. Whichever one you decide, you know how good you know. So before entering the industry, better you learn it properly and enter. Because there nobody will going to teach you. And you'll struggle there. Clear with this? So before you enter, learn it like this. Do you have any questions here?
Drawbacks of Java.
Huh?
What are the drawbacks of Java?
Very few. Negligible. Very, very few. Because what are the drawbacks? I don't find any.
Then why we have to develop the C#?
No, nobody uses C#. No, it's a competitor for Java. We don't develop applications in C#. See, for now one language came from one company. Another company is also trying to give one more language. Why? To make money. They are commercial. But we developers will choose our own for our own comfort. Which language is having big market, we choose that. Java is having big market. C# is having less market. You don't have to learn both the languages. It is following Java, I said. Means if you know Java, you can easily learn what? C#. But you will not do it. Understood? Are you clear with this? C# is also used for what? Internet programming. But Java is having history of what? 1991 to 2013. 22 years. 23 years. C# is having history of how many years? We don't know. But C# at the same time is not portable. If you write the code in C#, it will run in only one operating system. That's the main drawback. But if you write the code in Java, it will run in any operating system. If you write in C#, it will run in only Windows. Nowadays they are trying to make it portable. Okay, like if you write the code in C#, you can run it in Linux also. But for that you have to install an intermediate software. Now that intermediate software, what it will do? It will bring down the performance. Understood? It will be portable, but the performance of the language will reduce. But Java is not like that. It is highly portable and has got strong performance also. We'll see how it happens. I've still not started teaching you Java. As I start teaching you Java, you'll understand how reusability is, how portable it is, all that you'll start getting the answers. Yeah?
So any advantages of C# over Java?
Nothing. Zero.
Sir, for freshers, for recruitment process, companies will give test on C++. So after learning Java, can you able to attend that test C++?
Question is, for attending interviews, they'll give test on C++. Many companies will give. Till now, when you're going for interviews, what exactly happens is, the methodology of your preparation is wrong. Exactly what happens? See, there's a company. Okay. And you say you're from computer science. But in your resume, you'll be mentioning only C, C++. Some people will not even mention Java. So if they put Java question to you, what will you answer? It was not there in my syllabus. So your colleges have not trained you properly. Understood? Company there, I told yesterday, 95% of the companies in Bangalore are working on what? Applications. And heavy requirement is there for Java only. Understood? So, but since you give that complaint, what? I don't know Java and all that. So what they do, they give the test on C++. Reason is, at least if you are good in that, they'll try to hire you and train you. That's all. If you are, the interview is on C++, doesn't mean that you are going to work on C++. They are checking only your analytical skills and aptitude skills through that language. Understood? But supposingly you do Java. Okay, before you go to the interview, actually you should know about the company. What you should know about the company? You should go to their website. Tomorrow interview is there. Infosys interview is there. So you have to know about their company. What are the different kind of projects they are developing? Okay, and for developing those projects, what languages they are using. So all that you should update yourself. And that time if you update, definitely you'll come to know that most of the time the requirement will be for Java itself. Understood? And if it is Java, that time what happens, most of the companies will be asking you questions on Java only. Very rarely you'll get questions on what? C++. And by chance if they are asking questions on C++, it will be like what? That company is working on C++. Now Java companies will not take C++ interview for you. C++ companies will not take Java interview for you. C company will not take Java interview for you. If you go to Huawei, they will not take Java interview. If you go to Samsung, they will not take Java interview. So refer to their website. It will tell you clearly what type of applications they are developing. Accordingly you prepare and go, no? You have to prepare. Understood? But you don't have to prepare so many languages. Because 95% of the companies are working on Java. As a fresher, all this is confusing for you. Because zero guidance has been given to you in colleges. So what guidance they are not given to you for 4 years, how will I give it in 4 minutes to you? It is practically impossible. So over the period of time you will get the doubts cleared. 4 minutes I cannot clear all these doubts. So gradually you start understanding what is the actual interview process, how things are happening in the industry. Yesterday I gave an insight into the industry. Today I am talking little more. Tomorrow I will talk little more. Day after tomorrow a little more. Slowly I have to groom you.
Sir, since Java has everything, so why can't C and C++ be replaced with Java for embedded systems? Why?
It can't. This is solving one particular problem. C is solving one particular problem.
Sir, give an example.
See, can you take class like me? Can I sit like you and listen to the class when you take? No. We are irreplaceable. This is a very simple example. C cannot replace Java. Java cannot replace C. They have their own functionality. For understanding that, you have to understand the subject. Without understanding the subject, how will you compare C and C++? Now I will ask you one question. Simple. Let's forget C, C++, Java now. If I ask you English is good or Kannada is good, what will you tell? Can Kannada replace English or English replace Kannada? You give me the answer for this. They have their own importance now. Is Chinese good or English good? Is Russian good or English good? You are telling like that. Chinese people will tell Chinese is good. Because you know English, you are telling English is good. Chinese people will tell what? Chinese is good. Okay, now I will tell English and Kannada, which is good. What will you tell? Kannada is good, no? Why? Mother tongue. So we can't compare. They have their own preferences. Okay, and you can really compare only when you have professionalism there. Only when you have professionalism there. And that professionalism you'll get. As you go on learning, you'll learn. Neither do you know C, nor do you know Java. You don't know anything here. C also you don't know, Java also you don't know. How do you ask me to compare now? In C, what do you know? Tell me now. I'll compare it with Java. In C, what do you know? Tell.
So C has structures and all those things. So in Java we have classes.
C has structures, no? Java has how many? What do you mean by a structure?
It's a collection of some same things.
Structure is collection of same thing.
Same things like.
Who said that?
Attribute.
Structure in C is a user-defined data type. Simple. You don't know how to define structure, and you are comparing C with Java. Okay. C has got how many user-defined data types? How many it has got?
32.
Huh? 32 user-defined data types. First study C properly. C is having only 2 or 3 user-defined data types. Which one? Structure, enum, union. First learn C properly. You are telling you know C. What do you know in C? 32 data types you are telling. Where are 32 data types in C? Now Java is having how many user-defined data types? 6. So you can see the richness. It becomes like that. Next, what do you want to compare? Ask. Only one is sufficient. Huh? So first learn the language, then we can compare. One language only you don't know properly. And how do you want to compare? How do you expect that to compare with Java? Understood? So Java is having libraries. C does not have libraries. Understood? So like this, there are a lot of discussions to happen. One class, how will I give the, means see, a language which is having history of 50 years, how will I compare it in 5 minutes? Practically impossible. And I can compare, yes, I will compare Java with C. But the fact is, if you know C, I can compare, no? Do you know C? You said you know. And you know what answer you gave now, just now. What is the structure means? Collection of what you said. Some answer you gave which I can't answer also. Yes or no? But you are telling that C is that, means it's having structures and all that. Basically, structure is a user-defined data type. That simple definition you can't tell in C. Okay, but and it is having only 3. Java is having what? Many user-defined data types. 6. Not 3 also. 6 it has. Except landing. C is poor. Except landing. Brilliant in Java. Understood? Then memory management. You have to do. Java, implicit. C is not portable. Java is portable. C has no libraries. Java has plenty of libraries. What more do you need? This is just introduction. Understood? This is just introduction. Okay. Security. C is very weak because of pointers. Security. Java is very rich because of some concept. You'll see. Like that, if you go on comparing, they are having so many advantages. But again, C is used for a different set of programming. Java is used for a different set of programming. Okay. System side C dominates. Application side Java dominates. System side no openings in India. Application side lot of openings are there. Learning C is very difficult. Learning Java is very easy. Still more comparisons you want? To your level I told. Understood? More I tell, tomorrow I will not be here. So your ability, capacity is only that much. And I have to carry you through a very smooth process. Gradually, every day, little, I have to tell. Clear? So this is one story. Just I gave you some differences. Some differences. Story is big. Unnecessarily, nobody will invent language here. Nobody is going to invent language unnecessarily here. Reasons are there, and that history, 25 years of domination in the market itself is telling how Java is dominating. 1991 to 2013, 25 years of domination. No language has got this kind of a domination. Understood? Scalability you take, multi-threading you take, remoting you take. Java is the best. And these words you can't understand now. If I tell, what will happen now? What will happen? Java is difficult. Yes or no? So let's not bother that. Let's learn the language first. Yeah? So this is the story now. So next what I'll be doing is, see, we are going to learn Java now. As I said, Java is having great scope, easy, okay, very powerful programming language. And as the course progresses also, I'll be comparing this with what? It's not that I leave off Java here itself. Definitely all your programs, when I'm coding anything, I'll be comparing Java with C and C++. Definitely I'll be comparing. And you'll be knowing the benefits of it. But as and when the coding starts, I'll compare. Not now. Yeah? Okay. So we are going to learn now Java on Windows 7, 2007. Windows 7, okay, 32-bit operating system. This is what we are going to learn. Clear? So what I'll do now, so first, before getting into Java, tomorrow only I'll be showing you all the installation and all. Okay, just I'll give you an idea into what is operating system, and I'll be showing you all the some folder structures here, how we maintain and code. So first I'll show you the folder structure. Okay, first I'll show you the folder structure. See here, see, many people join cluster for doing course. Understood? I think, yeah, first I'll talk about Windows 7, then I'll come to this one. First I'll talk about Windows 7 and then we'll talk about our coding structure here, folder structure. First I'll talk about this. See, right now I'm having we have to learn Java, but to learn Java little you should know about what? Operating system. Little, not too much. So I'll be teaching you operating system from what? Java point of view. Not too much in depth. All of you know operating system. But how much of the operating system is required from Java point of view? That much I'll cover. Operating system is a very big subject. Understood? That's a different subject. Just I'm showing you how much related to Java. That's it. See, this is a brand new machine. Brand new machine. Nothing is here in this operating system. Only I got Windows 7 installed here. Nothing is here. So fine. And if you want, you can check. There is something like C drive, D drive, E drive. 3 drives are there. In C drive, nothing has been installed. Then in D drive, there are 2 folders. Just I'm showing you. E drive, cluster softwares, 1 folder is there. That's it. Okay. So I'll explain you completely what this is. This setup is. So first, initially, let's look into the operating system. We have got a brand new machine and there is nothing installed here. Only Windows 7 has been installed. So let's learn a little about the operating system. I'm still not teaching you Java. First, understand what? Operating system. Okay, because this don't club it with Java now. Understood? So fine. You know in Windows how to go to DOS prompt? How do you go to DOS prompt in Windows? Windows R means shortcut. Window R, you'll get this prompt. Type CMD. Okay, and you press enter. You'll go to the DOS prompt. Understood? So here we can type anything. Like example, I can type cd ... You know this now? So what will happen? It will bring one parent folder. It will come to the parent folder like that. So if you want, okay, I can close this. Again, I'll open one more. See this? Windows R, you type CMD. Windows R CMD. Okay. See here, I can type more commands. CALC. What do you mean by this? I'll press enter, calculator will open up. But fact is, calc, if I type there something, no? What is this? In fact, it is internally an exe file. It is internally one exe file. Okay. So if you execute that exe file, this application will open up. There's one calc.exe file. The name of the file is what? calc.exe. So you type in DOS prompt, calc. Don't type the extension. Automatically this application will open up. This is one approach. I'm just teaching you operating systems here. Or that is one support. Or you can go here and click here also. This is UI style. That is DOS style of running an application. This is Windows style of running an application. So you can start running your application from Windows also or from DOS also. In Windows, you click shortcuts. It will actually internally run the exe file. In DOS, you have to type the exe file. So there you should know the name of the exe file. So you can start anything there, browser, Internet Explorer, anything you can open. But you should know the name of the exe file. Since we don't know, we use the UI style because it is more user friendly. Done now? Fine. Similarly that, now see, I can go and type. Again I'll go to DOS prompt, Windows or CMD. Okay, type enter, you'll come here. Now see, notepad. Now what is notepad? Another exe file. Getting it now? So you can run this exe file from DOS prompt also, or you can go and select start, options and click on notepad, it will open up. End of the day you are running what? You are executing exe files. Clear? So fine. So that's how the DOS works. I'll type Ravi here, R-A-V-I. You'll get an error. What is the error you are getting? Ravi is not recognized as internal or external command error. Noticing now? Why? Because Ravi.exe is not there. So if the exe file is there, it will execute. Else it will give the error like this. Are you clear with this? Okay. Then fine. More things. Now what happens is, so many exe files are there. Okay. All these exe files are present, and when you install operating system, default, see, when you, now how does this command get executed? Next you might have a question. Okay, this is very important, not only from Java point of view, but from computer point of view also. See, whatever you type in the DOS prompt there, actually what happens is, the Windows operating system refers to one variable by name. It's the name of a variable name is called as path. It is case insensitive. Either you can write path, capital path or small path. It is case insensitive. Okay. So whenever you type anything in the DOS prompt or click anything in the UI, okay, it will be actually referring to this path variable. This path variable will be having the location of the exe file. Where is that exe file? This I'll show you very clearly now. Clear? So this is the variable. So we are studying Windows now. Okay, I'm just showing you what is calc and how they get executed and see this. So for seeing what is the value of path variable, okay, so what we do, you can go to DOS prompt now, CMD, type here echo. 1 second, okay, just see this. Now one more, before I go there, path, just see this. Echo is one more command I am executing. It's one more exe file. Exe file it is. I'll type echo Ravi. What happens? Prints as it is. So it's something like printf. Whatever you type, it will print. I'll type echo cluster. It prints. Means it's something like printf. In C you say no, printf hello world, like that it prints. Same way echo is something you give, it will print. So we saw some echo is also an exe file. Echo is also an exe file. What this exe file does, it will take the value what you have given and print it back into the console. That's how it works. So if you want, you can see here echo path. If I type, what happens? It will print path only. It will take it as a value and print. Understood? But I don't want to print what it means like path. I want to print actually the value. It's a variable name now. I want the value in the variable to be printed now. Like see, in C language, if I say printf %di, so what will happen that time? The value in I will be printed. I don't want to print only I. Printf in double quotes, if I put I, what will happen? It will print I. But I want to print the value stored in I now. Understood? So that's how you do it in C. You will say printf %d something and I, you will say somehow you will get the output. Okay. So here also I want the value stored in path to be printed. So that is when we say echo %path %. So if I do this, see what happens. It prints me some value. So this is the actual value which has been stored in the path variable. Are you clear with this? So if I want, See, this is the value. I'll press enter. I'll open on notepad. I'll paste it here. I'll increase the font. So see this. See, these are the different values which the path variable is having. So whatever you type, first it will go to this location. You type anything in the DOS prompt or you double click anywhere, irrespective, first it will go to this location and it checks whether the exe file is there in that particular folder or not. Understood? If it is not there, then it goes to the next folder. We have separated with semicolon, see there? So first it will go to this folder. See, if you want, I'll show you. I'll go to the Explorer, you paste that location here. It will come here. So here it will check, is that exe file is present. You understood how I went there? Go to Explorer, man, Windows, he will take you to what? Explorer, copy that path, this path you copy. This path you copy, and in the Explorer what you do? You paste it. Press enter, automatically it will show you. So like this you go searching, somewhere that exe file will be present. See, there are so many exe files here. So like this, whenever you type something, it will come to this, the path variable will be used. So in Windows, the variable name is used as path. In Linux, some other variable name is used. Don't think the variable name is standard in all operating system. In every operating system, this is how the exe files are getting executed. Remember this. Understood? They might have many exe files. In every operating system, this is how the exe file starts executing. In Windows, the variable name used is path. Are you clear with this? Fine. So somewhere it will search and finally it starts executing. Are you clear with this? It will search in the first location, not found, then it will go to the next one. Not found, then it will go to the next one. Not found, it will go to the next one. Just I'm showing you how it works. So somewhere it should be. So if it is not there, see, I'll type here. I'll type what now? Ravi. What will happen? Internal or external command. But it's very fast in searching. It will go in every folder. In 1 second it will go here, everywhere. Not doesn't find anywhere. It says not recognized as an internal or external command error. Some error message it will give you. Are you clear how the Windows is working now? Understood? So if you want to actually see the value stored in path, what we should do now? Not tell echo path, echo percentage path, percentage. And you can see the value. Are you clear with this? So this is one way to see the value stored in path variable. And when does this path variable get created? When you install OS now, automatically it will be created. When you install OS, it will be automatically created. One more way is there to see it. Here you can go. See, one more way to see the variable path variable is go to my computer properties. You go here, properties, and you can go to advanced system settings. I'm coming back again. See here, computer properties. Here, where will you click? Advanced system settings. Then here, what will you click? Environment variables. And here you scroll down. See how many variable names have been created. See here, not one, many are there. I'm just discussing about one variable name. What are the different variable names you are saying? ComSpec, FP underscore number of something like this. So these are all variable names. See, it's very clearly telling variable and the value stored in that variable. So these are the different variables which will be used by Windows OS. Understood? So this is very important. If you are a computer, means if you want to enter IT industry, these things, irrespective of which one you are going to learn, testing, C, C++, these are basics what you should learn. No. Understood? These are really small basics of the operating system what you should know. So focus on this now. So one of the variable name, if you scroll down here, you can see one of the variable name, or if you scroll down you can see it is here, path. So here you click edit and you copy this. Edit you say, don't say what is that. See here you are having options, edit. Select it and say edit. So you will get that. Control C you do. Again you can come and paste where. In notepad you can paste. You can see the value like this also. So this is the value. So this is the value. But here you are seeing something different. C drive, Windows, System 32. But here what you are saying? Percentage system root, percentage something like this, System 32. But actually system root is also one more variable. And the value of system root is, you know what? Can you guess what is the value of system root? Yes. It is also on variable name. And value for this is what? Can you guess? Guess. Huh? This is the value. Understood? Now you replace, it will come correctly. C drive Windows / systems 32. System root is also one more variable. There it will not display. Means see in the UI, means when you are dealing with this, advanced system settings, or where is it? Okay, here what happens? Okay, here what happens? It will not show it to you fully like that. But actually the value of system root is C drive Windows only. But display is like that. Display is what it is showing you, percentage system root, percentage / like that it will show. But actual value of system root is also what? Replace it. It will become, here path is on variable name, system root is on variable name. Value of system root is C drive Windows. Now finally what will become the value of this one now? What is the value of path? This one now? Actual value of path is what? System root plus that one. Like that it comes up. Anyway, don't bother too much about this. Just I'm telling you how they have, how in the operating system all the things are configured. Understood? How they are configured. So we are studying OS. I'm still not teaching you Java, because tomorrow if I start teaching you Java and if I teach you this, you'll get confused. So that's why before I teach you Java, I'm teaching you a little about OS too. Yeah. So fine. This is how the things are getting executed here, and fine. This is about path. So you can see the path here also in the DOS style, or if you want you can type echo percentage path percentage, and there you can in the DOS prompt, in the environment variables also you can see it. These are the two locations, but here you have to type echo percentage path percentage, it will show you the value. But there UI style, you click, it will show you the values. Whichever option you want, you can prefer. Done? Any questions here? I will not save anything, and cancel everything. Don't change anything here, because you make any changes there, the entire operating system has to be reinstalled. You are seeing it now, so many variables are there. So that's why I see here advanced system settings, environment variables, so many are there. And all these variables are used for what? Execution. You manipulate anything here, things will not work now. So that's why don't manipulate. Just I showed you how the things have been set. Any questions here? You understood what is the OS? Fine. So once you have installed OS, generally, see in our lab, okay, path. Okay, if you want you can write on small notes. Small, tomorrow we'll go deeper into this. Path is a variable name used by Windows operating system. Path is a variable name used by Windows operating system. Path is a variable name used by Windows operating system. Then next is the Windows operating system uses the path variable, uses the value stored in the path variable. The Windows operating system uses the value stored in the path variable to locate the exe files or binary files. To locate the exe files or binary files. To locate the exe files or binary files. It is used for that. Okay. Okay. Next point you write. Path variable actually contains path variable contains the location of the binary files. Simple word for you. Contains the location of binary files. It will be containing the location. Understood now? It contains the location of what? Binary files. Fine. So we have installed Windows. It's ready now. Next, see in our lab here, that you have to clearly understand again. In our lab, we have Lab I'm telling. We have, after that we have got only two drives, C drive, D drive. Tomorrow I'll install Java. Whatever softwares I install, it will be kept where? C drive. So you'll be only installing softwares here. Do not keep anything in C drive. I'm telling you how to code from tomorrow. You install software in only C drive and don't save any program in C drive. Usually it's a practice. When you code now, you'll save it on desktop, wherever you want to store. But you should not do like that. If you store like that, tomorrow you can't be able to refer to your own files. Understood? And if you can't see, today I'll teach, tomorrow I'll teach, day after time, tomorrow I'll teach, I'll go on coding now. So suddenly you feel that you want to refer to 3 days back program. Where it is now? You start searching. If you don't find it, what will happen? You will not like to type again. Boring, no, to type again. So what will happen? You will not type, you will not refer. If you don't refer, what will happen? You will not understand. So always, which program you want, it should be neatly organized so that in 1 minute you can access it. To do that, see what approach we are taking here. Any program you want, it will be accessible in 1 minute now. So let's see what we do. So here only we install software. Many softwares we are going to see now. Java or database, so many things. All will be installed on C drive. So no data will be kept on C drive. And if you try to keep also, it will not save here. Okay. And if it is kept also by chance, we delete it off. Your data will not be recovered later. We delete it off. So even in if you're coding, some people will start using laptop. So set your environment in the same way now. Or in your home you might code, wherever you're coding now. So set your environment like this. From today you go and set your environment completely like this. Keep Windows 7 ready. Keep this folder structure ready. In your home, this is optional. In lab we do this. In home, you can have one more drive for your personal purpose. Set it clearly like this. C drive, D drive, E drive. So here you will be E drive will be using for what? Personal use. So in D drive we'll only have what? Programs and programs, nothing else. Keep it neat and clean. So because see, coding is not important now, organizing things is important because we'll go on configuring many things. And as we go on configuring, your things might not work in home. So before in hand only I'm telling you how to prepare your OS or your laptop, because you might code it. If you're coding here, things are ready, no problem. But if you're thinking to use laptop and code in home and all, better you follow this structure. So in D drive you will have two folders now. See, C drive, D drive, E drive. E drive will be for what? Personal use. Now in D drive you will have two folders. One is edit plus underscore example. See the spelling you see now? See the spelling? Like this only you have to name. And don't give any other name. And here also in all the labs we are having this name only. Eclipse underscore examples. One more is edit plus underscore examples. So we are going to code now. Java. Tomorrow we'll start coding. So when you code, okay, see we can use, there are many editors to code one Java language. You can use Notepad, you can use Edit Plus, you can use TextPad, you can use Eclipse. So many editors are there for you to type. Which one? These two means the Java language. So initially we start off with Notepad, then we'll move to Edit Plus, then I'll move to Eclipse. Initially that will be the process. So whatever we code with Edit Plus and Notepad, save your files in this folder. Whatever we code in Eclipse, save it here. So it will be organized now. Understanding how you are organizing. Fine. Now in Edit Plus examples, next you can see there are so many months. Not only in Edit Plus, you have got it in Eclipse also. See what is there? Months are there like this. Okay, even in Eclipse what you are having? Months are there like this. Okay, means first we'll see Edit Plus only. So many months are there. Here what is happening? You can see what is a month? April 2012, April 2013. We have already created this folder structure. Why? Because so many people are going to code. If all of you go on saving in Edit Plus examples, who will understand whose code now? So that is why what we do here, this is the folder structure. So yours is what batch? August, no? So August underscore 2013. There is one folder already there. If it is not there, create it. But use the same convention. Don't type August fully. If it is not there, you'll have to create one folder. But don't type it fully. AUG, UST and all that. What you will do? One convention will already be there. AUG underscore 2012. Same you try to type now. AUG underscore 2013. Here also should be caps, no small. Follow conventions. Because tomorrow you'll be working in one machine. Later you'll go to another machine now. When you go to some other machine, what happens? It's irritating to see that folder name now. So all of us will maintain one standard folder name now. Understood? And moreover, see all our systems are on network. Tomorrow you don't find, you get that machine. and you have got some other machine to code now. So you want to program from that machine to this machine. Fine, it's on network. Just copy one folder from there to here, over. You'll get all your programs. That is how easy it will become. Else every day what you'll have to do? Only search for programs. Yesterday's program where it went, tomorrow's program where it will go. It'll be very difficult to maintain and manage. So that's why practice this. Make it a good habit now. Okay. So August 13. In this now here you can create your folders. I'll create now Ravi Kumar, Ashwin, Balaji, something like this. We can create our own folders. We can create our own folders. Are you getting it now? So it means whichever batch you belong to, create your folder. Understood? And in Ravi Kumar, what I'll do, again I'll create folder by name Core Java. And here, means see, I'll be teaching you many things. Core Java I'll teach, HTML I'll teach, SQL I'll teach, many things. JavaScript will teach. So that's why Core Java is one folder, SQL is another folder, HTML is another folder. Like that, Ashwin also will create these many folders. Ravi Kumar will create so many folders, Ashwin also will create so many, Balaji also will create so many folders. Right now we are doing only Java, so that's why Core Java folder will be there. In Core Java, again you have what? Java examples. This will be the folder structure. I'll write it here. See, this will be a directory structure now. Edit plus examples. Inside that what you'll have? August 2013. Inside that what you'll have? Your name. Inside that what you'll have? Many folders. Depends on what topic I'm teaching. Core Java, SQL, HTML, JavaScript. Okay, CSS. Many things will cover. So go on adding. So in this Core Java, what will happen now? Java examples. And here we start coding. 0, 1. Whatever the topic, I'll teach you on simple program now. Here you'll have one folder. And this folder I'll create it tomorrow. In that you'll start coding. Just I wrote sample file. And there your files will be saved. So first type program will be kept in first folder. Tomorrow I'll code something. So that will be kept in second folder. Then I'll code something. That will be kept in third. 0, 1, 0, 2, 0, 3. So you'll only understand now which file was stored in which folder. And which 0 represents the first day of coding, 02 represents the second day of coding, and with proper names we'll give. I'll teach on concept. Example, I'll teach encapsulation. So 02 encapsulation. Then I'll teach inheritance, 03 inheritance. So which program is there in which folder, automatically you'll be able to refer. And you can identify it easily and you can learn it also easily. You can refresh very fast, you can access your code now. And once you complete the course, you come and tell us you want to take your folder. Just 1 minute we'll write it in DVD and give all the programs what you have coded. You can take it also, so easily it will be. So tomorrow you are working in some other system. Just copy one folder now, which one? Ravi Kumar you copy into August 2013, finished. All your files are there, you don't have to wait for the machine now. So like this, if you organize, you can keep on coding in a better way. Otherwise you'll have to wait for only one system and your files will not be accessible and all that. And one more advantage is, see, tomorrow some problem happens in the software. Format C drive. Your data is safe in D drive now. So that's why we follow this directory structure. Clear? So I'll create this directory structure also for you today. So tomorrow is the first class of Java. Okay. So meanwhile, what you do? So this is what is there. Okay, 1 second. So what we'll do now, this is yours, is August 2013, right? So what will be the name now? New folder. What? Ravi Kumar. One more folder means another person, if he's coding now in the same system, what will you do? New Ashwin. So depending on his name, you can give full names and don't give any space and don't use any caps. All names should be in small case. Nothing special in between now. Ashwin Kumar, Ashwin Kulkarni, Ravi Kumar. See, neat and clean. Don't give space, don't give initials. If you want to give initial, without space. Ashwin Kumar Kulkarni H, fine. But no space, no caps. Maintain this, it looks neat and clean. Understood? So neat and fine it looks. Maintain the standards. Fine. Like that many folders will come. Next, in Ravi Kumar, what will happen now? What folder I will create? Core Java. Like this many folders will come. I may teach you what? SQL database. So that you keep it here. Then later on I may teach you what? HTML. You can save that here. So like this we'll go on creating multiple folders. Clear? So then in Core Java, what will happen now? Java examples. In core Java, we'll have Java examples. And here inside this, we'll start off coding. What? 0, 1, 0, 2, like that. We'll start. I think, 1 second. Java examples and core Java. I think no, we'll do one thing. Outside folder, we'll make it as Java, I think. Core Java examples, and inside we'll make it as core Java. Clear? So sorry for that. Really sorry for that. I think outside we'll make it as Java examples, not that. Outside will be what? Java examples. Outside Java examples, inside core Java. 1 second. Let me rectify it here. See this? What is the folder structure?
Core Java.
Yeah, Java examples.
Core Java.
And inside this, core Java. Clear? Clear this? Okay. So from tomorrow, we'll start working with this folder. So this is one thing. Just a small change. Correct? Java examples and core Java. Fine. So then next is, if you want for this also, you can add suffixes. SQL examples, HTML examples, and all that. Understood? For Java examples, we'll be going with core Java. Here, if you want, you can do this. Because see, the name of the folder should be self-explanatory. So when you look at your folder name, you should know what it contains. That's the idea. Clear? So in Java examples, we are dealing with core Java. So done. I think we are done with this. Then fine. So I introduced operating system. I told you where we are going to save the files. Then next, one more thing what I have to cover is here. Once you join cluster, a DVD will be given to you. In your home, if you are trying to work now, you got one more space now, E drive. So in the DVD we give some softwares. Once you join cluster, you will be given some DVD which will contain all the softwares which you want to train you. So copy all that software into E drive, cluster softwares. So here they are in this is the folder we will be giving to you. And all the softwares we are giving to you is here. Okay, it is in compressed format. Why it is in compressed? It is easy for us to give it to you. Okay, so many softwares have been given to you. So just copy it. Just copy it. Okay, and in tomorrow, this is Java. In Java, I will be showing you how to install. See, it is compressed. So you'll have to extract it and install it. So from tomorrow, I'll continue the class from this now. Where? How to install Java and how to get the first Java output. Clear? How to get the first Java output. Tomorrow I'll be getting into this. So today I just gave you history of languages, why so many languages came into existence, why Java is popular. Okay, and Java is used extensively for what? Internet programming. Okay, and then we saw OS, how the OS looks for the exe files. Okay, then I showed you our coding folder structure. And then finally what? The softwares, what will be given to you and where you will keep it in your computers. Okay, but if it is in cluster, in lab you will not be finding E drive and the softwares are already installed. In lab you will not find E drive. Just I told you how to organize your computer now. So by tomorrow when you come, keep Windows 7 ready. Okay, Windows 7 ready with this things arranged. By chance, if already you are having data in D drive and all that, you create only one folder now called as personal use and shift all the data into what? E drive.
Sir, I have Windows 8.
Reinstall, because we are going to teach you configuration. So you might have different OS in your home. Now don't think latest, old and all that. All of us are going to learn Java in one operating system. So what output I show you, it should match with you in your home. So that's why it's better you reinstall that to Windows 7. That's why I'm giving you time today. I didn't teach you anything. I could have shown you installation of Java. So I want you to get prepared for that. This folder structure and all that. So even in fact, when you take this DVD, all the softwares will be present there. Understood? The DVD begins. So if you want, you can take Windows 7 also from here, they will give it to you. But keep it ready. Tomorrow I will be showing you how to install Java. Immediately you should go and try to install it in your place also, and then what? Coding will start. Don't delay a single day also. Because if you delay one day, what will happen? Things will pile up. Every day you should be in constant sync with me. Understood? So today, first day only I can tell how to keep your operating system ready, so that tomorrow we can start off installation. Understood now? Directly if I type first day program, what will happen? It will be very difficult for you. So that's the reason, keep all these things ready. Clear? Any questions? So, any questions? Okay, so we're going to learn Java in a very clear way now. So tomorrow I show you the first installation process of Java. Come prepared. Okay, that's it.